Tēnā koutou, tēnā koutou, tēnā koutou katoa, ngā mihi nui ki a koutou katoa. Hello everybody, warm greetings to everyone. I'm Gerard Rowe, I'm the Deputy Dean Academic in the Faculty of Engineering, and I'll be presenting this Futures Evenings tonight, along with Oti Alfroza, who is one of our Part 4 Computer Systems Engineering students. So I'll be doing roughly the first half of the presentation. Oti will then present the next third, and then I'll wrap up the presentation. Thank you. So, welcome. What we're going to do tonight is give you a feel for what is engineering. We'll talk a little bit about what goes on in the first year, because that's of most interest to school leavers, but then we'll talk about what the students should do in their first year in order to get into the specialisation of their choice in year 2. We'll talk about the entry requirements for the 3 most common routes into engineering, and I'll also talk about some alternative pathways into engineering via the BSc, but we'll also talk about another option known as a conjoint, where you actually study 2 degrees. We'll look at some real-world projects that are undertaken by our students in years 2, 3 and 4 of the degree, and also talk about some exchange opportunities. And then at that point I'll hand over to Oti, who's going to tell you about student life, about the academic support that we provide to our students, and about the Women in Engineering program and the Dean's Leadership program. And then I'll take back the presentation. We'll talk a little bit about some targeted entry admission criteria. We'll talk about scholarships, career opportunities, and the accommodation options that are available in the university. So we'll start first of all with a little bit of housekeeping. For most of you, this will be the first time at the University of Auckland. This is one of our 2 largest lecture theatres. It seats 569 students. There's an equivalent theatre 1 floor above, and a number of other theatres that we can video link to on this floor. In the very unlikely event that anything will go wrong, some audible alarms will sound, and you should exit the lecture theatre through the back entrance, the one you came into, and then head to your right, and there's an exit out of the building on the right as I face those doors. Should you need to use bathrooms, just head back through those doors and they're across the foyer on the far side. This would be an ideal time just to check that your cell phones are on silent mode. And if you haven't done so, after the presentation, do make sure that you register in the foyer along to my left. And if you have registered, you'll be given a bag which contains a range of items, including a frequently asked question sheet, or at least links to the website where you can find that particular information. So my first task this evening is to tell you a little bit about engineering, what engineers actually do, but we're going to start with a video, and this video is set up to represent what a new student might experience as they enter engineering. So if we consider what is engineering, I'd like you to keep three thoughts in your mind. Engineers are first and foremost problem solvers. Secondly, we're innovators. And thirdly, what we do makes a huge difference to people's lives. Whether it be working with drones, as Theo is doing on the slide behind me, or optimising the design of a sail, such as Rebecca is doing on this particular slide, or measuring tensile strength in a structural member, such as Joseph is doing on this particular slide. In each case, the engineers analyse the problem, they come up with a range of possible solutions, and then they implement the best solution, taking into account both technical considerations, but also the interests of all of the stakeholders who might be affected by this particular engineering project. So engineers are first and foremost problem solvers. But the sorts of problems that we work on make a huge difference to people's lives. Engineering is a very good career in terms of security of occupation, of employment, and of remuneration, but it's more than that. People who choose to do engineering usually do so because they do want to make a difference. And at the end of the day, you go home knowing that you've done something that improves people's lives, such as the medical devices that Andrew's working on the slide behind me. And finally, engineers are innovators. And what they do is they make the world more accessible, whether it's the healthcare robots that Rosa is working on in the slide that you see before you now, or whether it's working on improvements to the internet, to smartphone technology, to transportation. Engineers are innovators who make the world more accessible. So we're problem solvers, we're innovators, but above all, what we do makes a difference to people's lives. So if you choose to come and study with us at the University of Auckland, you'll be entering into a 4-year Bachelor of Engineering honours degree. The last year, the honours year, is taught at postgraduate level. The program is taught entirely on the city campus. So all our lecture theatres are here. This is where we do the teaching for this particular program. In your first year, when you're studying here, you're extraordinarily lucky because we've been constructing a new building in engineering, across to the left. It opens 2020. We take possession on the 1st of November, so we'll be shifting all our equipment in over the summer. So you're going to be the very first cohort to use our building, which is purpose designed to incorporate a huge number of flexible learning spaces. So we're trying to redirect our teaching to actually reduce the amount of this sort of lecturing and to make it much more active and engaging. There's always a place for some lecturing, but it's going to be reduced, as you will experience in your first year with us. So if you study here, we have a semestral system. You study 4 courses in the first half of the year, semester 1, and 4 courses in the second half of the year, semester 2. So if you look at the slide behind me, roughly the left-hand slide you could think of as first semester and the right-hand side you could think of as the second. The only complication is that the top left, general education, can be studied in either semester, and top right, EngGen 115, engineering design, can also be taken in either semester. But with that slight flexibility, your first semester will contain the maths, engineering mechanics, and EngGen 140 courses you see on the left, and your second semester, Chem Mat 121, Elect Eng 101, and EngGen 131. So if we just look briefly at each of those courses, general education is a requirement of all of the University of Auckland degrees. So no matter what degree you do, you have to take at least 1 general education course. In most degrees, you have to take 2. So it's a broadening experience. You select a course from a list we provide, which takes you into studying topics that are quite different from engineering or closely related science topics. The second course that you'll study is in the first semester is Mathematical Modelling 1. Now, as the name implies, it's obviously a maths course, but it's maths taught in the context of applying it to real-world problems. So you're taught how to model real-world problems and then use the appropriate mathematical tools. The next one down, Engineering Mechanics, builds on the mechanics and the physics courses that you'll all be studying. and it covers statics and dynamics. It's taught jointly by our civil engineering department and our mechanical engineering department. The next one down, Eng 140, if you were studying with us this year, it would involve a combination of biology and chemistry, and we introduced it a number of years ago because we believed that by the time you're mid-career, there'll be a convergence between the life sciences and the physical sciences. Now, we still believe that, but we've decided to change the course slightly starting from next year, and you'll see the name has changed, and it will be taught as a course entitled Engineering and Society, so it's still using elements of chemistry and biology, but only those elements that relate to energy. And in particular, we'll also be using this course to introduce you to key elements of what it means to be a professional engineer, ethical responsibilities, social license to operate and the like, taught in the context of applications within the field of energy. Now, the next course that you'll do either in the first or second semester is engineering design. And what distinguishes an engineering degree from, let's say, a science degree, one of the distinguishing features is design. We teach our students how to design things that products or systems that have not existed previously. And we need to teach you to work in groups. We need to teach you how to deal with complex, open-ended problems, to deal with situations where you don't actually have all of the data, so you need to make assumptions. And we step you through that over the 4 years of the program, so you'll find design courses in all 4 years of every specialisation that you actually study, starting in Part 1. We also use that course to further reinforce what it means to be a professional engineer. So there are elements coming into that course involved with ethics and the like that also are preparing you for your professional careers. In the second semester, you'll study a course on materials science. It assumes no prior background, but it teaches you about the key properties of materials so you can use that to engineer a vast range of products in the various specialisations that you might study. You'll take a course on electrical and digital systems. This builds on the electricity part of the physics courses that you're all currently studying. And finally, you'll take a course on engineering, computation and software development, which teaches you about programming. And again, it assumes no prior background. If you have done some coding before, that's great, but if you haven't, it's not a problem at all. At the end of Part 1, you will be asked to select the specialisation that you want to go into. So we use Part 1 to give you a feel for all of the different engineering specialisations, and there are lecturers teaching in those courses who come from all of those specialisations. We also run a whole lot of events during that first year where you get further information on what is involved in the particular careers, and we also arrange for you to be able to interact with students such as Auti who are studying in those specialisations, so you can get information from people who are actually studying as to whether they thought they'd made good choices or whether they'd do something different if they had their time again. So at the end of Part 1, you make that choice. We ask you to give 5 choices and rank them from 1 to 5, and we do our very best to assign you to the specialisation of choice. Coming up now is the available spaces in 2020 for the current 9 specialisations that we actually have. We'll have reps here tonight from all of those specialisations. They'll be in the foyer where you probably registered earlier this evening to talk about the various options in each of these specialisations. If you are absolutely set on getting into a particular specialisation, the best thing you can do is do as well as possible academically in your first year, because we use your grade point average in your Part 1 courses to actually assign you to your specialisation of choice. Generally, we get most people into their first choice, but some will inevitably get their second choice. We have one change coming on stream that will widen the set of options. We are at the moment seeking approval for a new specialisation in structural engineering. So at present, the Civil and Environmental Engineering Department have a single degree in civil engineering. What we will do, provided we get approval, is that they will run 2 degrees. The first 2 years of those degrees will be in common, and then they'll part company in their 3rd year. So that there'll be a standard civil degree, pretty much the same as what we have now, but if we get approval, there will also be a structural engineering degree, which will be available to students entering in 2020. So remember, in part one, the best thing you can actually do to get your specialisation of choice is do as well as you can academically. So we'll change tack now and we'll talk about entry requirements for school leavers coming into engineering part one in 2020. And the first thing I want to talk about is our academic English language requirement, which applies to all degrees at the University of Auckland. So over a number of years, the university has analysed the student performance data to work out what makes for successful academic studies and conversely, what leads to students falling into the academically at risk category. And what we've found is that one of the key indicators of likely academic risk is poor academic English. So we have a heightened requirement above university entrance literacy standard, which is called the Academic English Language Requirement, and you can see it spelt out there for the 3 most common entry routes and for some other ways that you might come into the faculty. Now, if you don't meet this requirement, it does not stop you entering the university, but what we do is we grab that general education course that I mentioned a few slides back, and instead of giving you a totally free choice, we require you to take an academic English language course which will strengthen your English. So this requirement won't stop you entering, but we know from past experience that we do need to bolster people's academic English. Now, down the bottom of this slide, you'll see a mention of an acronym DELNA. That stands for Diagnostic English Language Needs Assessment. Every new entrant into the University of Auckland, regardless of what degree you're doing, that includes PhD students, is required to undergo this assessment. And it's pretty brief. First assessment takes probably only about 10 minutes, and if you pass that, it's done and dusted. If you don't manage to pass that, then there's a more detailed assessment which takes a couple of hours. And again, most students who fail the first assessment would pass the second. But if you don't manage to pass that, we enrol you in an online course, again, to bolster your English language. We also do pick up some other issues here, such as undiagnosed dyslexia and things like that, that might be barriers to your future study. So every student coming into the University of Auckland New will do the DELNA assessment. They normally do it during orientation week. So if we turn then to the various requirements, I'm going to talk only about the 3 most common entry routes into engineering. Roughly 80% of our entrants come in through NCEA and a smaller number through Cambridge and even smaller through International Baccalaureate. Before we go into the details, I'll just explain the structure of this slide. You'll see that on this slide and the next 2, there are 2 guaranteed entry numbers given at the bottom of the slide. The first one is for those who are studying a Bachelor of Engineering Honours degree. The second one is for those who are doing a conjoint degree, so that's the BE Honours and something else. And we'll talk about the conjoint degrees a bit later on. Now, the guaranteed entry score often creates more anxiety than really it should. This is our means of protecting us from simply being overwhelmed with too many students, which would exceed our ability to provide a good learning environment. So the government funds us for a certain number of places. We enter into a contract with the government for those places, and we set the guaranteed entry score so that we don't exceed those by too significant a margin. But our intention is always to accept entrants below those scores. The only time in recent history where we haven't done this is immediately after the Christchurch earthquakes in 2011, when students, particularly from the rest of New Zealand rather than the Auckland metropolitan area, chose to come to us rather than to Canterbury. Now that, fortunately, that's all settled down. The University of Canterbury is almost back to its pre-quake numbers. In fact, I think it may actually have exceeded them. So now we would expect to always go under the guaranteed entry score. In the case of NCEA, and indeed the other 2 qualifications I'll talk about, We know from our analysis of what makes for a successful student experience that you need to do enough physics and enough mathematics. There are key gatekeeper concepts in those two subjects that if you haven't studied them, you are just going to struggle in engineering. So for that reason, we have requirements for those three programs on what you should do. In the case of NCEA, because both physics and calculus are compartmentalised, we've identified particular achievement standards that you must achieve a pass in. So for physics, it's electricity, it's waves, and it's mechanics, and for calculus, it's integration, differentiation, and complex numbers. Those achievement standards just simply contain gatekeeper concepts that you need to master in order to be able to study successfully here. We calculate your guaranteed entry score over your best 80 credits, and sometimes we do flex a little bit on the required achievement standards, provided that the guaranteed entry, provided that your rank score is high enough. So if you don't meet those particular achievement standards, talk to some of our admissions staff. It doesn't necessarily mean that you can't be admitted. If we look at Cambridge, again, a university entrance standard, and then we calculate your rank score over your last 2 years of high school, years 12 and 13, and we again expect you to have studied maths and physics, ideally to full A level, but provided that the rank score is high enough, we may accept on a case-by-case basis AS maths or AS physics, provided your rank score is high enough and provided you did well enough in the AS maths or the AS physics. And finally, for International Baccalaureate, again, the entrance requirement is the full IB diploma, ideally mathematics and physics to the higher level, but provided that the rank score is high enough, on a case-by-case basis, we do admit people with either standard level maths or standard level physics. For this year, there's been changes in maths. So for higher level maths, we're looking either for analysis and approaches or for applications and interpretation. Either of those is fine. In the case of students who may be seeking entry with standard level maths, the only one we'd accept is analysis and approaches. In our view, the applications and interpretation would not set you up well enough for study in first year engineering. But if you've got any queries about that, a number of our student centre staff who handle admissions will be in the foyer after this presentation, and please do talk to them. So suppose you didn't meet those requirements, but you were dead keen set on coming into engineering. There are actually a number of other pathways. So only one of them shown on this slide. And again, if it pertains to you, talk to our admissions staff after the presentation about what options are available. But one of the alternative routes in is to enrol in a BSc, but to choose your courses from a list that is available on both the engineering website and the science website. And we hold 30 places available in Part 1 for second semester entry, but those 30 places are obviously keenly sought after by students who are on this pathway. So once again, it's their grade point average that they achieve in the first semester that will be used to decide who actually gets in. We do require a minimum of a B average and at least a B in the relevant maths and physics courses. If you're coming in via this route, depending on what you studied, you may have to take a summer school course to actually catch up as well. For some students, though, this wouldn't be the best route, and for some students, we would strongly advocate that you spend a full year in the Bachelor of Science and build up either your maths or your physics, depending on which needed a bit more support. For other students, we might suggest that you enrol in one of our foundation programs, and we have changed the foundation programs so that students can be conditionally admitted via a foundation program to their faculty of choice. And with a foundation program, you study 7 courses rather than 8. But if you do well enough in your first 4 courses in semester 1, then we will let you take one of the first year engineering courses in the second semester. And the one we would let you take is actually the design course that appeared on an earlier slide. So I've mentioned a couple of times conjoint degrees. A number of students coming into engineering have a dilemma. They want to study engineering, but they're passionate about English literature or music, or they'd like to do an engineering degree to develop street cred in the sort of science, but their passion is actually to get involved in national or even global policy making, so they may study global studies. Others may want to move into patent law, but want the street cred that comes with studying the engineering degree first. So if that sounds like you, explore the options available for a conjoint degree. So that's what's currently available. In general, it takes about 5 years to complete a conjoint degree. So the normal BE honours, it's 480 points. In the case of a conjoint degree, you do 420 points. You effectively don't have to do 1 semester of study. It's absorbed into the conjoint degree. Most of the conjoints take 5 years. Law takes 5.5 to 6, depending on whether you're doing the LLB or the LLB honours. But if you've got a dilemma and you're both interested in engineering and something else, check out the conjoint options. And I'll take a brief break and I'll get one of our former conjoint students to tell you a little bit about that.
All through high school, I took French and history alongside my sciences and maths, and I really wanted to carry that on. I didn't want to just give it up at university. So studying a conjoint degree, it's really like the best of both worlds. It just balances your study life out, and I've found that I'm enjoying both engineering and arts a lot more because I get the diversity of choosing what I want to study when I want to.
So part of being an engineer is learning to work on extremely complex projects, open-ended projects, no single right answer, multiple stakeholders who may disagree quite strongly over whether the way the project should be done or even if the project should be done at all. You need to know how to work in interdisciplinary teams. You need to know how to work with non-engineers, people from a non-technical background. You need to have a little bit of financial and political nous to understand the other factors that bear on a successful project. So the way we do that is via a combination of activities in the design courses that are embedded through all 4 years of your program, and also through a set of professional development courses which are developing your mastery of the extra skills, the non-technical ones that you need to be a successful engineer. So we have a whole series of real-world projects, as authentic as we can possibly make them in this sort of environment, where we gradually get you used to working in increasingly larger teams, in interdisciplinary teams, so that you're working with students from quite different specialisations, working on very open-ended complex problems, getting used to dealing with problems where you don't have all of the data available, so you have to make sensible assumptions and you have to check what the consequences are of particular variables changing. So those real-world projects have their culmination in our final year. So in the second semester of the final year, we actually cancel 1 whole week of lectures in week 9 of the second semester, and students work in very large interdisciplinary teams, typically about 25, which involve all 9 specialisations. They work on a complex real-world scenario, and what we're doing is we're setting the problem up so that they integrate the knowledge, the technical knowledge that comes from the disciplinary courses that they've studied with project management, with increasing mastery of innovation, and also we introduce the concept of risk and of opportunity and entrepreneurship, essentially, etc. So those projects, we cancel a whole week of lectures and the students work exclusively on those. I'll let you hear from some of the students who've gone through that.
My favourite project would be the airport extension, and there was a group of 10 of us, and all of us came up with different ideas, and the result was just amazing.
This term we got given a systems project was to create a movie. Personally, I hadn't really thought of myself as being very creative, but over the time that we spent creating this movie, creating the whole script, there was a lot that we had to do that involved creativity, which I found quite exciting.
The biggest buzz was on the last night. All the team stayed up till 2 a.m. trying to get it finished, and the next morning we had it printed out, bound, and it looked amazing, and there was just this big buzz.
One of our goals across the university as a whole is to create graduates who can operate globally. So an important part of that are the exchange opportunities that are available in all of our degrees. So via the 125 partner universities that we've set up agreements with in 25 countries, it's possible for you to study overseas for 1 semester of your engineering degree. Now, we don't permit it in part 1 because we want to get you used to university and introduce you to what it means to be a professional engineer. You can study for 1 semester, or the second semester of part 2, you could go overseas, or first semester or second semester of part 3. We don't permit exchange in part 4 because our research project runs across both semesters and we need you actually physically here. If you do exchange, then you can credit your study back to this university, but of course it gives you the opportunity to experience different cultures, see different places, and obviously to enhance your experience and your CV. So you might fear that Central City campus like this, it might be a tad boring. You might be thinking, should I move out of Auckland, explore some of those more exciting campuses that we've heard about down south? Well, I can assure you that we have a vibrant student life here, but I'm not the best person to describe that. So I'm going to ask Auti to take over at this point to tell you about student life.
Awesome, thank you. Oh, can you hear me? Yes. Hi everyone, so as Gerard said, I am Auti. I'm a 4th year computer systems engineering student, and I'm here to talk to you a bit about student life. So to begin with, I'm going to say if you've seen me speak at events before, sorry, it's going to be different near the end, but this little bit about me section will be the same. So I've lived in Auckland since I was 5 months old, so my entire life, and I went to high school at ACG Parnell College. I've always been interested in problem solving and puzzles and maths, but fun fact, I didn't like physics that much in high school. And I'm currently studying computer systems, which is a little bit of software programming, but then also understanding machines that run the code. So the great thing is I don't touch physics at all right now, and I love it. But yeah, so until my first year at uni, I had actually never done programming. I thought I was going to hate it. I thought it was really boring until I realized it's just problem solving that earns you money. Great. But yeah, and once I finish this final year, which I'm off to work as a developer at TradeMe, which I'm super duper excited about. I actually worked an internship there last summer. And something that helped me get my job at TradeMe was the clubs that I was involved in and all the opportunities I'd had at university to kind of grow and make friends and make connections. One of the most incredible things I find from coming to Auckland Uni is you're surrounded by people not only from different parts of New Zealand, but also then once you're in part 2 and 3, there are some people that come here on exchange and you get to meet them. And so you get to connect with all sorts of new people, you get experiences, and you really get a chance to grow. So when I talk about student life, I want you to keep in mind that sometimes when you think about university, you just think about the academic side of things, you think about the job you'll get at the end, but student life is really important, not only because it helps you become a better person and all that, but also uni can be really tough, it can be really hard, and at the end of it, what you're going to remember the most is the cool experiences you have. Yeah, and so I'm going to give you a little taste of all the different clubs we have, both in the faculty and then wider wider University of Auckland. So, firstly, AUSA is the student association that we have here at Auckland Uni, so that's not just for engineering, and they organise a lot of really fun events for students, particularly in orientation week, and this is one of the events that goes on, which is Party in the Park. And the great thing about these is it means that when you meet someone in class and you like get through the whole, oh, what high school did you go to? Okay, and then you're like, well, what do I talk about now? You go, oh, are you going to this? Have you heard of this? And it's a really nice time to have some built-in small talk. And they also have a bunch of support around for students as well. And aside from AUSA, we have a bunch of engineering-specific clubs. And the thing I like about these is everyone in these clubs do engineering, so they understand the time commitment your degree is, and how much time you can actually give to a club. And also you'll find that some people are in this club and other people in this club, and then these people are in both those clubs, and you start just meeting everyone's friends, and it really helps kind of build that close-knit community that we end up having in engineering. So this one is the Formula SAE team. So if you saw in the little robot video, there was the little robot like working on the car. So this is a team about 40 engineering students, and they build a race car, and then they take it to Australia and they race it against other universities that build cars. My best friend from high school, Lizzie, she's the blonde in that corner on the right-hand corner. She did all I knew in high school. All she did was she liked cars, thought they were cool, didn't know anything about them. First year she joined the team, and then last year ended up being team leader, which is really, really cool. What was I going to say? Yeah, so that's an example of one of the things where maybe you don't know too much about it, but then you can join a club, you can kind of get skilled up, and then she ended up getting a really cool internship at McLaren over in England, and I'm pretty sure this would have helped. Another great club is AUES. So that is the Engineering Society. It's a student-run club, and they organize a whole bunch of events for students. So a lot of social events that involve dress up, as you can see there. But they also have professional development events and community-based events. For example, 2 months ago, they went and did a beach cleanup at Takapuna, and there's lots of really great ways to meet other students within engineering. People from first year, second year, third year, fourth year, all come along, and it's a really big thing in the engineering faculty. And this club is called the Engineering Review, and this is the nearest and dearest to my heart, so I'm going to talk about it a little bit. So it is a live show that is entirely run, written, created, performed by engineering students. We perform it in Sky City Theatre, so it's a real production with a lot of money that goes into it, and it's really, really fun. And this year, I joined in my second year, and this year I'm actually producer, which means I'm kind of the big boss. It's very exciting, and it means I'm basically managing the production side. So when other people are like, oh yes, I've done group projects at uni, and I'm like, yes, I've managed a cast of 100 people and an exec team of 15 and had to deal with companies and all of that, and it's really cool. And so this has singing, acting, singing, music. We do our own tech, so we actually have a little first year tech team, which they run all the lighting and sound, which is really cool. And yeah, it's a good chance to try something really different. So the reason I'm really passionate about it is there are some people that have done theatre for many, many years, and then there are some people that have never even seen a live show, and then they come along, they get involved, and they try something completely out of their comfort zone, and they really grow as a person. I was actually shy back in the day, believe it or not, and then now I just don't stop talking in front of large groups of people. But yeah, and if you are keen to come watch the Engineering Review, we do perform in a month in Sky City Theatre, and you can get tickets online. If you go to the Engineering Review Facebook page, you can buy them. Just had to have a little plug in there. And the final club is the Wakaama team, and so they are one of the sports teams that we have here in engineering, and they compete nationally. And last year they won a trip to go and compete in Hawaii, which I think is really, really cool, and I didn't know that was possible, or else I would have joined because I want to go to Hawaii. Full disclosure, I totally forgot that video was in there, which is why I didn't say anything before it came up, but that was some student life there. The next thing I'm going to talk about is a bit about academic support. So I'm not going to read out the entire slide, I'm just going to summarize it because I'm sure you can read it. And basically, we know that a lot of people are stressed about what the transition between high school and university is like. If people have different subjects that they've done, different programs and all that. And so we have this thing called the Part 1 Assistance Centre, which is organised by the faculty, and they hire Part 2 and 3 students with high GPAs to literally come and sit in the communal engineering study space and help Part 1 students. So this runs every day, and the great thing is these Part 2 and 3 mentors then go back to the lecturers and say, hey, we've had a lot of students that are super confused about this thing that you went over in the lectures. Could you go over that in more detail? So if enough students go and get help on the same thing, then that feeds into the lecturing. Yeah. And that is Part 1 assistant team a couple years ago.
Engineering is about creating change, solving problems, and making a difference to the world. And engineers do this using creativity and collaboration, science and mathematics, to shape and create almost every aspect of the world that we live in. And we believe that everyone should be represented in that process. The Faculty of Engineering at the University of Auckland is committed to encouraging more women into engineering and to making sure that their time with us is full of learning, full of inspiration, and full of opportunities. We have the Women in Engineering Network, which organises social events and gives opportunities for professional development and networking. We have fantastic lecturers who are dedicated to inspiring our students to pursue their passions. And we have the Women in Engineering Advisor, who supports all of our female students throughout their journey with us and helps them to make change in the world. Let's hear what some of our students have to say about their time with us.
Studying in the Faculty of Engineering is really fun because I think it's a really cohesive faculty. It's really cool seeing how passionate some of the lecturers are about what they're teaching, especially in first year classes, to hear all the experiences and all their own personal research that they bring into their teaching.
They have a great organisation called the Women in Engineering Network, and they're very supportive, so they really value the female students.
I came from an all-girls high school, and I'd heard the stories about so many more boys in engineering than girls. But when you sit down in your lecture theatres, it's not a big deal. You just get on with it.
So we've got Michelle Dickinson, Bryony James and Rosalind Archer, who are just really, really brilliant lecturers, and they just inspire me to sort of push more, be better at engineering.
In 5 years, I could be working in any number of fields. I could be a researcher, I could be in software, maybe I'll be in consultancy.
You get a lot of exciting projects as well. We had a project in my 4th year where we got to design and test out a little robot that extinguishes miniature fires. So it would detect the fire and it would go along and put it out, and it was so much fun.
Sweet, so the next thing I'm going to talk about is women in engineering. So hold up, sorry, I've lost my place. Yes, so this network is actually something that helped me choose to decide to do engineering before I came here. So it is a network, as was said in the video, that helps support students, female and gender diverse students, as they come into the faculty, and then also we go out to schools and we try to tell girls about engineering in case they don't know about it. And we have a number of mentorship programs. We run our own orientation where girls can meet each other and make some friends, and we have a range of social events and networking events with industry. Now, this isn't because girls need support academically, it's more because for some reason, I don't know why, but engineering is seen as like a guy's thing. There's probably a reason that somehow this happened, but we just like to do this because this is a nice way to kind of help even the scale a bit. So here at Auckland Uni, we have, our first year cohort this year was 29% female, and that may not seem like a lot, but it's really good, and it is getting higher and higher every single year. I went to a co-ed school, so I was used to being around guys all the time. I came to engineering, didn't feel like anything changed, and I've talked to a lot of my friends that went to all-girls schools, and they were like, oh, it was chill, it was fine. But if you aren't sure what to expect, or like they said in the video, you've heard horror stories, it's nice to have that kind of extra support. So my older sister actually studied law, and she had quite a biased view of engineers. And so when I said, I think I want to do engineering, she's like, engineering's full of boys that are socially awkward and they can't make eye contact with a girl and they'll never speak to you. And I was like, oh my gosh, I'm going to be by myself. It's going to be awful. And no, she was wrong. It's fine. I came along to an information evening. I met girls in engineering and guys that were studying engineering, and I was like, oh, they're just normal people. We're good. So yeah, we're just kind of there to help out here and there. And if anyone gets involved in the WEN leadership team, we have a lot of really cool events and things like that, and we have our own little leader retreat. We go to the Waitakere Ranges, play some fun games, do some workshops and official things as well, and it's a good time. And the last program I'd like to talk about is the Dean's Leadership Program. So this was a program I was involved in second semester last year. This is our cohort. Last year, I'm in the bright yellow right there next to Helen Clark. I was so stoked. And she came in and did a intimate Q&A with us about her time as Prime Minister and then also her time in the UN, and it was really fascinating. And so this is a program that's open to all engineering students, and they take in 10 Part 2 students and 20 Part 3 students. And GPA doesn't actually matter for this. They care more about what ideas you put forward in your application and your interview. And it's a unique opportunity to not only get a taste of hearing from leaders and developing a lot of those soft skills that you don't get in class, but also for me the best part was meeting a bunch of other students that I probably wouldn't have met in that way, who were all incredibly driven, incredibly inspiring, and I met, and we got put into these little mini groups that they'd be like, go hang out. And my little mini group and I, we still hang out to this day. Whenever one of us is stressed, we're just like, need coffee chats. And then we go and we just talk about everything. And the great thing is you get a lot of support to kind of push yourself. And it's really lovely. And I'm going to say one final thing before I hand you back to Gerard. I know I've said a lot of things. And if I recall from my information evenings, things go in one ear and then out the other. But I just wanted to say, in my very, very biased opinion, that engineering, especially here at Auckland, has an incredibly good culture. The fact that we have a first year that isn't competitive means that everyone is super friendly, super willing to help, and you get a lot of opportunities to meet with people. And we also have a lot of really lovely clubs filled with people from all specializations, all years, and they're all really welcoming. So remember, university, it's more than academics, it's more than a job. You want to make sure that you grow as a person, because at the end of the day, no matter what you study, if you don't take that time at uni to meet these new people and do all these cool things, you're not going to grow as a person, and then you're not going to really go, enjoy yourself. So yeah, say hi to strangers in your class. No, it's terrifying. No matter what you study, just say hi. You'll make friends, I promise. And yeah, be brave, be nice, get involved, have fun, and if you end up studying engineering here at Auckland, I am very, very excited for you. I absolutely have loved my time, and yeah, thank you.
Thanks very much. Auti's spoken of our aspirational desires to increase the number of women who are studying engineering. We also have similar aspirations to increase the number of Maori and Pacifica students. So we're 29% women, 4% Maori, 4% Pacifica. We want to grow the Maori and Pacifica cohort. So we provide, as do all the other faculties, a support network, the Tuakana network, that provides dedicated Maori and Pacific orientation, tutorials, exam preparation events, provides dedicated study space for the SPIES group that I'll talk about in a minute or two, strong cultural and support networks as well. And the University of Auckland also runs a targeted admission scheme. So this applies to Maori and Pacifica students, but it also applies to those from a lower socioeconomic background, to those from a refugee background, and to those with disabilities. So if you are part of any of those cohorts, go onto the University of Auckland website and check out the targeted admission schemes as well. Now, in addition to the Tuakana Support Network, one of the clubs that we have, a large club as you can see, is the South Pacific Indigenous Engineering Student Society, normally referred to as the SPIES Network. So again, they provide social support and networking, academic support, and they've also helped the faculty tremendously over a number of years with outreach activities to make the opportunities available in engineering widely known within the Maori and Pacifica communities. So as we come to the conclusion of this evening's presentation, there's a few reminders I need to alert you to. First of all, if you're interested in studying here, you should check out the scholarships that are actually available. So go on to the University of Auckland website, check out the scholarships. Some of them close very soon. So the set that you see on the slide behind me, they're open now and the closing date is the 20th of August. Some of these scholarships will require references, generally from your high school teachers, and some of the scholarships also do offer, or in some cases require, that you spend your first year in the halls of residence. And the reason for that, once again, is that we have got cast iron evidence that one of the things that leads to success at university is engagement, and those who are actually staying in the halls of residence don't have the long commutes, etc., so it leads to more successful outcomes. So a little later I'll show you some details about our accommodation as well. Now, another set of scholarships that are faculty scholarships are the ones that appear on this slide. The closing date for those occurs at a rather inconvenient time. It's when New Zealand's largely shut down for its summer holidays. The applications typically open about 6 weeks before a closing date, so it's opening late November, early December. Again, check those scholarships out. The Kickstart scholarships, there's 22 of them. The award is $2,000 to set you up with set-up costs for your first year of study, but there's another 40 engineering scholarships available on our website, so do check those out. These are the Kickstart recipients, or some of them from from a year ago. But I'd also like to acknowledge one of our major supporters. That's the Auckland University Engineering Association. That's our alumni association. Everyone who completes an engineering degree automatically becomes a member of that alumni association. Since its inception in 1957, it's been a very generous supporter of the faculty. It provides a range of scholarships, and the most recent addition to its portfolio of scholarships is the AUEA Maori and Pacifica Pathway Scholarships. They're open at the moment, so if you are likely to be eligible for those scholarships, do check out our website and make sure you get in an application. Now, if we turn then to career opportunities, all 9 of our specialisations are accredited under an international accord known as the Washington Accord. Now, the consequence of that is that it makes for easy global mobility. You could complete an engineering degree here and then you can go and work in the countries of the signatories to the Washington Accord as though you had completed a Washington Accord accredited degree in that particular country. So it obviously opens up a whole range of opportunities for you. The demand for professional engineers exceeds the supply in virtually every country, New Zealand, Australia, Canada, the US, etc. But I'd like you to also recognise that what we teach you here is a set of transferable skills, so your opportunities are not simply limited to what you might perceive as obvious engineering opportunities. We will ensure you have good quantitative skills, that you're good problem solvers, that you're good communicators, that you're good in working in teams. Those skills are transferable, they're sought by a whole range of industries. About this time of the year, the merchant banking industry comes around looking for our top graduates, but we have a graduate from this faculty as a Member of Parliament. We have graduates working in national and international policy. There are a vast range of opportunities, not simply limited to the obvious engineering opportunities in manufacturing, in infrastructure, and in consulting. So we also have a dedicated employment manager who runs a series of events, employer evenings, when they come in to talk to the students. We have career fairs to help you see what opportunities are available and to line you up with either internships to tick off some of your practical work or maybe your first job. We maintain a database of employers, 4,500 of them, who have provided suitable practical work opportunities for our students. Now, as part of our requirements under the Washington Accord, all graduates of the BE Honours are required to undertake 800 hours of practical work. So that's normally done in the summer in 2 periods of 400 hours. It can be done in New Zealand, but it can also be done overseas as well. So we maintain this database of prior employers to help you secure suitable practical work. Now, I mentioned earlier that some of the scholarships that we have available require you to actually stay in the halls of residence. But Auckland's a large area, and there may also be people here tonight who have come from further afield who may also want to stay in our halls of residence. So we're going to finish with a couple of slides, a video and then one slide, to tell you a little bit about the accommodation options that are available at the University of Auckland.
I chose to live in a hall of residence because firstly I'm from Hamilton, so I'm not from Auckland, so I don't have family living here. And I thought it would be a lot easier to transition from living at home to flatting by going to a hall of residence first, so that I could get to know the city a bit more before I went flatting by myself.
I chose uni hall because I had a lot of recommendations from friends who stayed here the year before. It's less than 5 minutes from the campus, so it's really close if you need to go to the library or to the commons to study. Living in the city of Auckland is a pretty big change as well for me, coming from a rural area.
Living in a hall in your first year is really important because of all those connections you make and forming that support group around you, especially when you're coming to a new city. If you like to study by yourself, you can study by yourself. But also if you want to study in a group, there's always other people around that you can study with.
Here at the hall we have a well-stocked games room as well as a big screen TV downstairs. In our common rooms we have TVs as well, so we can easily watch movies with the floor, have floor bonding nights.
While I've been at Huia, I've been on the Wakaama volleyball and basketball teams, and all of those events have been really fun. That's another great way to socialise with the people of your hall. You come together as a team and you really bond, which is really nice. You have everyone around you to keep you going, and you have the person in your boat that calls, and everyone motivates each other while you're on the water as well. There are a lot of things that are convenient about a hall, such as how close you are to the campus. Huia is about a 10-minute walk from city campus and 15 to 20 minutes to Auckland city centre. Everything's just a walking distance away.
Coming from parents who make the best home-cooked meals to mass catering is quite a big change for me, but for feeding 450 kids, they do it really well.
One of the great things about a hall of residence is that you always feel safe, it's secure. It's not just the physical security, but mental security in the way that you have a lot of people around you who can help you if you're needing help, or you can go to one of the RAs and you can always talk to them if you're having any issues with anything.
Staying at uni hall is probably the best decision I've made here at the university. You have 450 people that are your age, 30 odd people down your hallway you can easily meet. You just make friends so easily.
So some brief details. We have 4 halls of accommodation. They have smaller single rooms and larger single rooms. You'll see the prices per week midway down that particular slide. They're all fully catered, and the most distant is 15 minutes walk to our general library. Others are 5 or 6 minutes away. So if you need any information, just check out the web link at the bottom, accommodation at auckland.ac.nz. It's easily trackable through the main university website. So that brings us to the end of our presentation, but a number of my colleagues have joined us. They'll be available in the foyer where you registered so that they'll be able to talk about any of our 9 specialisations. We also have staff from our student centre who deal with the more difficult admissions issues here. So if you have any concerns about admissions, please find the table that's dealing with that. Just a couple of reminders that you'll see of upcoming events on this slide. Our open day takes place on Saturday the 31st of August, and Engineer Her Future Day in the second semester is on Thursday the 12th of September. So in closing, I'd like to thank our marketing and events team who put a huge amount of effort into putting this event on tonight, and I'd like to thank Aote for her particular presentation as well. That was fantastic. It's really difficult to present to an environment here, so well done, Aote.